So I tried to find you online and it doesn't look like you're online, but it's Friday. I want you to have a great weekend and I want you to watch what we did. In this unit, you learned about this. If I had x squared plus 6x plus 9, when you factored it, it was going to be x plus 3, and the reason why you got that was because you said, okay, 9 could be broken into 1 and 9 or 3 and 3. And then we just found that 3 times 3 gave us 9, which is what we wanted. But then also it told us that 3 plus 3 is equal to 6, so that's how we got our x plus 3, x plus 3. Now, we also looked at another thing that was called difference of squares, right? So now an example of that would be x squared minus 4. So let's say I wanted to prove that this was a difference of squares. So what I do is I check. The square root of x squared is just x, right? And then I take a look at the square root of 4. If I take the square root of 4 on my calculator, I get 2 back, right? Perfect. And then the fact that we have this difference in between, this subtraction in between, means we have a perfect candidate for a difference of squares. So all we have to write for our final factorization is going to be this. We put our x in each bracket, just like we did before. But then we have 1 plus 2 and 1 minus 2, and we are done. That is how we come up with the difference of squares. Now, let's imagine that I give you something just a little bit more difficult. So imagine if I have 4x squared minus 25. So here's the rule. Take a look at 4x squared. 4x squared, when you square root it, is going to be just 2x. And we square root 25, we end up with 5. Both are perfect squares, so we can rewrite this problem as 2x and 2x, and then plus 5 and minus 5 in our bracket, and we're done. Now, the area of the shaded region problem that we have is very similar to that. So here is our shape. So we got our shape, and we have x and x on the outside, but then on the inside we have a 3 by 3. So the area of the big part is just going to be x times x, because it's just length times width, which just gives us x squared, right? Now, let's go and take a look at the area of the small. The area of the small is just going to be, ready? 3 times 3, which is 9, right? Now, in order to find the area of just this shaded region, i.e. everything subtract the little red box in the middle, is going to be this. The area is equal to a big minus the area of the small part, which we know to be x squared for that one, and then minus 9. Now, if I look at that problem, I have a perfect square because I can take the square root of x squared, gives us x. The square root of 9 is equal to 3. So now that goes and allows us to write x plus 3 and x minus 3. And that is our factored form for the area that we were looking for. So A is equal to that factored form, and we're done. Okay, so for 11b, imagine that you have a box whose big length, the big paper box, is x going all the way across, right? And x going all the way across for the bottom. Now, here's the thing that we know, right? This is 5 centimeters and this is 5 centimeters, right? Now, if this was a big block, we would basically figure out what that little block was and then figure out what this little block was if our entire area was just x squared, right? And then what we would do is we'd go and take off those 4 blue boxes, right? So imagine I want to figure out the big box, A big. So A big is just going to be x squared, right? X times x, right? But then the small area is going to be, well, 5 times 5. But you got to remember, here is the kicker. There are 4 little corners that we're going to chop out in order to make our little box. So we're going to times that by 4. So 4 times 25 gives us a total of 100, doesn't it? So the area is going to be A big minus A small, which is x squared minus, well, the total number of the areas for the blues was 100, right? Because it was 4 times 25. And now, take a look at that. The square root of x squared is just x again. The square root of 100 is equal to 10. And you'll notice that in the middle, we got our, whoa, look at that. We got a minus in there. So we have a difference of squares, which is what we like, right? So that means our final answer is going to be x and then plus 10 and then x minus 10 for our final factorization form. And there is our answer again. Right, so for question number 14, they're telling us that the area of a rectangular garden is given by this. Okay? Now, I'm going to tell you what they're asking you. For question number 1, they're saying, give an expression of the length and width. So here's the rule. You know that area is equal to length times width, right? So if we go and factor what we have in our equation, then one of the brackets is our length and one of the brackets is the width of our shape. So we end up with A, and we're going to try and factor that thing up top. So we're going to have an x and an x, and then we're going to see 2 numbers that multiply to 10 and add to the middle number. So the middle number is 7, so 1 times 10 is 10, perfect, but 1 plus 10 does not equal 7, so that's gone. So now we're going to take a look at 2 times 5. 2 times 5 is 10, but 2 plus 5 gives us what we're looking for. So now we're going to just write x plus 2 and x plus 5. So one of these is our width, one of these is our length, and one of these is our width. Okay, so I'm going to say that this is my length and that is my width. And we are done. So you would say the length is x plus 2 and the width is x plus 5. All right? Now, the last part of the problem requires us to do some weirdness. So the last part of the problem is asking us to say, okay, so it says, all right, if the area equals 40, find the length and the width. Find L and W. So in order to do that, we're going to cheat. We're going to say 40 is the original equation. So 40 is equal to x squared plus 7x plus 10. Now, what we're going to do in order to get something that we can factor, this is not something we can factor right away. So in order to do that, what we're going to do is we're going to take this 40 that's on this side and we're going to move it to the end of this. And instead of being positive 40 on this side, it becomes negative 40. So we end up with 0 is equal to x squared plus 7x plus 10 minus 40. So now we end up with this final quadratic, x squared plus 7x minus 30. So now all we got to do is we got to find the factorization of this, right? And when we do that, this allows us to find the solutions for which that makes the right side of the equation equal 0. So here's what we're going to do. We're going to find two numbers that multiply to negative 30 but add to positive 7. Now I'm going to give you a hint. In the middle, if I know that two numbers are one number is negative when we multiply it and one number is positive, right? And you know that the middle number is positive, that means the smaller number has to be negative, because when we add a smaller number to a bigger positive number, we're going to end up with a positive number overall. So let's do that again. So negative 1 times 30 is 30, but negative 1 plus 30 doesn't equal the 7 in our equation there. So I'm going to cross that out. Can't use that. How about minus 2 times, say, 15? Minus 2 times 15. Multiply those out. Oh, man, that doesn't work either. Because when you add them up, it doesn't equal to 7, right? How about minus 3, and we're going to multiply it by 10. So 3 times 10, and then put the minus sign on the 3. So we end up with negative 3 plus 10 gives us 7. Ooh, perfect. So that means we have 0 is equal to bracket x minus 3 and x plus 10. So now they're asking us to find the length and the width. Now, based on this, if I was trying to find out what x's give my thing 0, give my original number 0, I could have x equaling 3, or, and I'll show you how that works, we just do the opposite of what this is in order to find out what number makes that entire bracket 0. So if I put in x is 3, 3 minus 3 gives 0. So for the last bracket, we got x is minus 10. Now your question should be, what is the length and the width? Now we have two possibilities. X is 3 and x is minus 10, right? Now let's go back and look at what we had before. You remember when we had created our factored form here, we had x plus 2 and x plus 5, right? You know that the length and the width overall has to be positive, right? Because there's no such thing as a negative length and a width. If I punch in 3 into this equation, the x plus 2, that means the length is going to be 3 plus 2 would be 5, right? And then for this other one, 3 plus 5 would be 8 for the width, right? Now, hold up. What would happen if we put in a negative 10 here? That negative 10, if I plug it in here, you'd end up with a length being negative 8. Whoa, negative 10 plus 2 gives us negative 8. That doesn't work. And I check over here as well. That doesn't work either. So guess what? Our final answer is not all three, not x is 10 or 8. We just have to say that x is not negative 10, but we will say, therefore, the length is equal to 3 plus 2, which is 5, and the width is going to be 3 plus 5, which equals 8. and we're done. All right. Okay, go have a good weekend, all right? Bye.